A two-dimensional array is like a grid or a table in which you can organize information. It has a collection of rows and a collection of columns. For example, a shoe stacking.
The example showed issue cabinet or shoe stacking. The cabinet has 2 rows and 3 columns. A shoe cabinet with 2 rows and 3 columns could be represented as a 2D array with 2 rows and 3 columns. Each element in the array would correspond to a specific shelf and column within the cabinet.
For example, the element at row 1, column 1 would represent the top left shelf in the first row, while the element at row 1, column 2 will represent the bottom right shelf in the second row.
In the case of a shoe cabinet with 2 rows and 3 columns, we can think of the 2 rows as representing the height of the cabinet, and the 3 columns as representing the depth of the cabinet. Each element in a 2D array can be accessed using 2 indices, one for the row and one for the column. For example, in a 2 by 3 2D array, we can access the top left element, which represents a shoe on the top shelf in the first row. Similarly, we can access the element representing a shoe on the bottom shelf in the second row. We can also access elements in between using this index notation or using a loop that iterates over the rows and columns. Overall, the 2D array is a powerful data structure that can be used to represent grids or tables of data and can be particularly useful for modeling shoe cabinets and similar storage solutions. Here is an example of me choosing shoes or sandals on each rows and columns. I pick the sandal from the first column of the first row, which represents the first element of the row, 1. Then I pick the shoe in the second column of the second row. It represents the second element of row 2. Then it goes on. A multi-dimensional array, also known as a matrix, allows for efficient storage and retrieval of data that is organized in a grid-like structure. Why multi-dimensional array is necessary and good? A multi-dimensional array, also known as a matrix, allows for efficient storage and retrieval of data that is organized in a grid-like structure, such as a table or a list. It is often used in applications that involve large amounts of numerical data, such as financial modeling, scientific simulations, and image processing. The advantages of using multidimensional arrays include
Storage efficiency. A multidimensional array can be more space efficient than a single-dimensional array. Improved performance. A four-dimensional array can improve the performance of certain algorithms, such as matrix multiplication, by reducing the number of operations required. Data organization. A multidimensional array can help organize data in a more structured and intuitive way, making it easier to understand and work with. Overall, multidimensional arrays are powerful and versatile data structures that can be used to represent and manipulate data in a wide range of applications.